Hi there, welcome to Million Lights. My name is Pratik Shah. I am an assistant professor in Dr. D.Y. Patil School of Engineering. In the previous video, we had discussed about the course, the learning outcomes, who should take the course, and the scope of the course in the industry. In this module, we will be discussing about embedded systems, the use of Arduino in embedded systems, why should we use Arduino in embedded systems, and the Arduino Uno components. These components will be bare minimum components that we will be discussing in this module so that they can be used in the embedded systems. Embedded systems. These are the systems which are designed for a specific task. For example, cameras, MP3 players, radios, TVs, refrigerators, AC, etc. etc. If we take example of an MP3 player, it is used for just listening to the music. Camera to click a picture. So embedded systems are basically a system that is designed to do just one task. Okay. Now embedded systems are designed for meeting real-time constraints also. So they should react in a real-time basis. So when I click a button of a camera, it should capture an image. We cannot tolerate the delay. When we click a play button, the music should be on. So they are also designed to meet real-time constraints. Now, for understanding embedded systems, we'll take an example, and that example is of a mall entry gate. Now, whenever we enter into a mall, there is a gate that automatically opens after detecting a presence of any human, and when we pass or when we go inside the mall, the door is closed. Now, we'll take that example, and along with that, we'll understand the block diagram of embedded systems. The block diagram of embedded system consists of input sensors, then a controller or a processor that is at the center. This is the brain of the embedded system, and then we have an output devices. These output devices provide or make a necessary action. Okay, so let us assume a scenario that you are entering into a mall. When you enter into a mall, there is a sensor called as proximity sensor that detects the presence of a human, and after it detects the presence of a human, it gives that signal to the brain or the controller. Now this controller can be anything. It can be 8051, it can be Intel, it can be PIC controller, it can be ARM controller. Now if you are not understanding these names, please ignore it, don't worry about that. So it can be anything, but the thing is, it should be able to understand and it should be able to produce some results. Now then this controller will give instructions to the output devices. The output devices can be motors, relays, etc. etc. and these devices make a particular action. So when we enter into a mall, a proximity sensor is there that will detect the presence of a human, and this signal is fed to the controller. That controller will take a decision, and that decision is passed on to the output device, which will be a motor in our case, and that motor will rotate. So when it rotates, the door is open, we go into it. After we pass the door automatically closes. Why? Because our embedded systems, that is our controller, takes this decision. So embedded system has got three parts. One is input part, second one is controller, that is the brain that thinks, and then an output part that will take the action. Now this is a very simple definition of embedded systems and is a very simple block diagram of embedded systems. Now if we want to design any embedded systems, it is inevitable to have these three parts: input, controller and the output. Now what can be the things that are there in the input? In the input we have sensors which can measure temperature, we can measure light intensity, we can measure pressure, we can measure the presence of any human being, we can measure the distance of any object. So these are input parts, these are input sensors. There are various sensors which we will be discussing in the module. These values are given to the controller, and controller measures these values, takes a decision, and then it controls the output device. Now what can be an output device? Output device can be a motor. Motor is used for producing any mechanical action. If we can control a motor, we can do anything. We can open the doors, close the doors, or do a lot of very different actions. Then we can switch on and off relays. Now relays are electromechanical switches. If we on and off relays, we can control lights, fans, ACs, TVs, etc. etc. So you can make an embedded system application that when you enter into your home, directly the lights will be on. That is very simple. You use an proximity sensor, give its input to the controller, and then controller will switch on and off relay, and the relay is connected to your tube. So directly you come into home, the tube will be switched on. In the same way, you can switch on AC and whatever you want to do. So this is very simplified way of expressing an embedded systems. So what all things we are discussing about embedded system output devices? We have our motors, we have relays, we have LCDs, that is liquid crystal display, that is used for displaying the stuff. In the same way, we have LEDs, and then we have buzzers and all the other stuffs. So basically, embedded system, input device, controller, and the output devices. What is Arduino? Now we are clear with basics of embedded system. Now we will see what is Arduino and how it can be used in embedded systems. But before that, let us understand what Arduino is not. First thing, Arduino is not a microcontroller. Microcontroller, as we have seen in the previous part, it is the brain of any embedded systems. So Arduino is not a microcontroller. Okay. The second thing, Arduino is not a manufacturer like Philips, Siemens, Motorola, etc., etc. These are the companies which prepare or make microcontroller. So Arduino is also not a manufacturer. Then what is Arduino? Arduino is an open source hardware platform based on Atmel AVR microcontroller and C++ based IDE. So let us split the definition and understand it. It is an open source hardware platform. Now open source hardware platform means all the implementation details of this board are available on their website. Means the IC that we have used, the PCB layout of it, then which pin is connected to which device, registers, and all these pins, all the layout and all these things are given on their website. So it is an open source hardware platform, all the implementation details are known, so you can also make this board. Okay. Second thing, it is based on Atmel AVR microcontrollers. Now Atmel is a manufacturer which produces series of microcontrollers such as Atmega 2560, Atmega 328, etc., etc. So they have a series called as AVR, Advanced Virtual RISC microcontrollers. So Arduino uses Atmel manufacturers AVR series of microcontroller. Okay. Then the third part, it is based on C++ IDE. C++ IDE. Now IDE is Integrated Development Environment. In the first example of mall gate entry, we have seen that microcontroller or the central part is the brain where it takes the decision and it measures the input values and takes a decision and gives signal to the output device. Now how does it think? It cannot think like us. We have to write a program or we have to give it instructions so that it performs the given task. Now for writing that instructions or giving that instructions, we need a software. So Arduino is also providing us with an open source software in which we can write the program, and after that the program is dumped or burned or uploaded onto the Arduino IC. So it is an open source hardware platform which is based on Atmel AVR controllers and a C++ based IDE. Now it is founded by Massimo Benzi in 2000 and the group. The photo is displayed in the thing in 2005. So from 2005 it is making waves. There are various different type of Arduino boards such as Arduino Uno, Arduino Leonardo, Mega, Nano, etc., etc. These various different type of board have a lot of different microcontrollers such as Atmega 328, Atmega 2560, and they have different input output configurations. The performance and the speed is also dependent on these parameters. So based on our application, we can select a particular board. In this course, we will be discussing about Arduino Uno, that is based on Atmega 328 processor. Why Arduino? Till now, we have seen what is Arduino and how we can use Arduino. Along with that, we have also seen the different types of Arduinos. Now, we will see why should we use Arduino in embedded systems. There are a lot of answers for this question. The first one is inexpensive. The cost of Arduino board is less than 500 rupees. Even if you go out and take a microcontroller, lot of microcontrollers cost is more than 500 rupees. So you are getting a complete system on chip for 500 rupees. So it is very cost efficient. The second one is simple and easy to learn programming. The programming language is the most hurdle or the most biggest hurdle in designing of embedded systems. That becomes the strength of Arduino. The programming language is very simple and even a 9th standard kid can understand it and implement it. So the programming language is simple. That is the second benefit of it. The third one is controller independent programming language. Now I would like to keep it in a note. there are a lot of controllers and each controller has its own programming language. If you use 8051, its language is different. If you use PIC, its language is different. If you use ARM, its language is different. So every controller, if you use Intel, it has different programming language. So each controller has a different programming language. But when you use Arduino, we do not need to go for that. The programming language of Arduino is designed by them and it is not dependent on controller. So that is the third point. The fourth point is one language compatibility with all boards. Now as we have discussed earlier, there are more than 15 variants of Arduino. Now the benefit of the programming language of Arduino is that when you learn one programming language of one board, so in this course we are going to learn Arduino Uno and its programming language, the same language is applied to all the 15 boards. So you master one programming of Arduino Uno, you will use all these things. So one board, you can use all the boards. So that is the most important thing, and we need not bother about which controller we are using. We are using ARM, we are using Atmega, we need not bother about that. We can understand one board programming and everywhere it is compatible. Then the fifth advantage is it is having single software for programming, compiling and burning the code. Now as we have discussed earlier, we have an IDE of Arduino that is based on C++. That software is sufficient for programming the code, dumping the code, debugging the code. So we have one software which does all the tasks. So what we need to worry? Nothing. We have a board, we have one software, that's it. Program it, check the code, dump the code, and it also has a serial monitor to do serial communication between the board and the PC. So one software for doing all these things. Now the guys from technical field will know that if you are using 8051 controller, you have one software for programming it, another software is used for burning the code from your PC onto the 8051 board. So that becomes a very difficult task. Now here one software for doing all these things. And one more extra benefit I would like to tell is we have just one board, and that board is designed in such a way that we can use it in a very simpler way. So what they have done is they have given pins for all the input and outputs, and those pins are like we can insert the probes into it and directly we can get it. Now if you use other traditional microcontrollers such as 8051, PIC, ARM, you will have to buy the microcontroller, you will have to provide it with crystal oscillator, resistors, you have to create an PCB, you have to go through these all steps which takes more than 4 to 5 hours. Now here you just have to purchase the board and you are ready to design an embedded system, because they have done all these things. Input output ports have given out, so you can directly connect it, program it, and you are ready to use. Arduino Uno components. Now we'll be discussing about 4 major important Arduino Uno components. There are lot of things in this board. Okay, so if you are completely new to this, you will not understand what exactly all these things are. So don't worry, we'll be discussing only 4 important things and we can directly go for our experiment number 1. The first and the foremost important is this thing. It is used for powering the Arduino. As you might be aware, any electronic device requires power for working. You might consider your mobile phones, they require power, laptops, PCs, TV, every electronic device requires power for operation. In the same way, Arduino requires power for operation. You can either connect a adapter of 7 to 12 volts in this power pin, then it will work, or you can also connect a power battery back. So you can take a battery and connect it with the port to this thing. So you can connect it with the help of an adapter or a battery, it is completely fine, but it requires constant power for working. Then okay, the Arduino is working on 5 volts, but we are taking an adapter which is from 7 volts to 12 volts, anything is okay, because we have got this 7805, that is 7805 IC that converts any voltage above 7 volts to 5 volts. So that's why Arduino works on 5 volts and we have got this 7805 which converts any voltage above 7 to 5 volts. This is regarding power. Now we'll speak about the second important thing, that is this USB port. This USB port is used as a gateway between our Arduino board and this PC. Now as we have seen earlier, we write the program in our PC or a laptop and then that program is dumped or uploaded on this board. Now for that purpose we need a medium through connection. So for that we have got this USB cable this portion of USB cable is connected to this part of our board, and this USB part is connected to our laptops or the computers. So this makes a gateway between our laptop or PC and USB. The same thing can also be used for powering up. When we connect our laptop to Arduino, there is no need to provide power supply from this. This 5 volts is sufficient to light up this Arduino board and it will definitely work. Okay, so second part was USB, and that was used for programming, uploading, dumping and execution. This is also used for serial communication. There are a lot of requirements where we want to communicate between Arduino and our PC. For example, you want to create a program in which you want to switch on the lights, the fans, or you want to do anything with your PC. So if you press a keyboard button 1, you want a tube to be on, you press keyboard number button 5, you want AC to be on. That can be done. How? Arduino is connected to tube and then AC with the help of a relay, and you can connect your Arduino and laptop through this USB port. So this is the second part. Then third part that we'll be learning is this reset button. This reset button is similar to the restart button in our PC and reboot button in your mobiles. So when you press this reset button, it will start working from the beginning. Okay, now comes the fourth and most important part of this, that is I/O, input output pins. We'll go back once again to the example of mall gate entry. There what we did, we had a central processing unit and that was connected to an input device, that is proximity sensor, and controller was connected to an output device, that is motor. Okay, so you know that we have to connect our controller to input devices and output devices. How to connect them? There should be some way with the help of which the communication takes place. For that we require IO ports. IO stands for input output. So input devices, output devices, all are connected through IO ports. Now totally in Arduino we have got 20 input output ports. So this we can see here, this part is digital. There are 14 digital IO pins from pin number 0 to pin number 13. In the same way, we have got 6 analog pins and they are from A0 to A5, A0 to A5. So we have totally 14 digital pins on the right hand side of the board and 6 analog pins on the left hand side of the board. So these are totally 14 plus 6, 20 IO pins where we can connect input or output sensors. Now IO pins are bidirectional. That means we can also connect an input device, along with that we can also connect an output device. Now 20 IO pins does not mean that we can connect 20 input output devices. Why? Because few of the input sensors or devices require more than 3 pins and few of the output devices require more than 2 pins. Now suppose we consider a motor. Motor requires 2 pins. So totally if you are connecting all the motors to this board, you can connect only 10 motors. If we talk about LCDs, LCD require more than 5 pins bare minimum operation. So we can connect only 4 LCDs. That too there is a thing, we have got digital and analog things. So we need to figure out, we need to learn what is digital, what is analog, we'll learn that. So just summing up, 20 IO pins are there. IO pins, input, output, anything can be connected. 14 are digital, 6 are analog. Okay, so now let us see what is digital and what is analog. Now digital means either on or off. This light is on, light is off, AC is on, AC is off. So either on or off, either 5 volts or 0 volts. We are talking about digital means we are talking about ones and zeros, that is 5 volts and 0 volts. So there are sensors which are digital in nature, there are output devices which are digital in nature. Now example of proximity sensor, we can consider it to be a digital sensor. If some person is coming, then it will give you an high signal, that is 5 volt signal to the controller. If nobody is coming, it will give you 0 volt signal, that is low or logic 0 signal. In the same way we have output devices which are digital, for example LEDs. LEDs are either on, that is they will glow, or they are off, that is they won't glow. So digital means either on or off. Done. So we have got 14 pins which do this thing. Now let us talk about analog. We have got A0 to A5, that is 6 analog pins. Now this analog pins, now first what is an analog? Analog is a signal that is not discrete. means it is not just 0 and 1, it takes any value. Best example of analog signal is your temperature. Temperature, we cannot say temperature is high or low, or it is on or off. Temperature can take any value, 25 degrees, 17 degrees, minus 18 degrees, any value. Pressure can take any value. Distance is not, yes, distance is there, distance is not there, nothing like that. 3 centimeters, 4 centimeters, 4 meters, 4 kilometers. So these are analog values. All the physical parameters are analog: pressure, temperature, humidity, everything is analog. So our embedded system is not good if it is only understanding digital things. So we also require analog ports to accept the analog values. That's why we have got 6 analog ports which will understand the analog values. Now there are few more details, we'll not go into that, we'll take that part in the second thing, such as analog. There is a resolution, there is an ADC, we'll skip it now, we'll learn it when we are understanding LDR. So this is digital part, this is analog part, we have seen them. Now along with that, few more things I would like to bring into focus. First one is that digital pins, we have seen that there are 14 digital pins, that is 0 to 13. In that you might see that in pin number 3, 5, 6, 9, 10 and 11 there is a dash sign that is placed after these ports. Now why is that? This is because these are capable of providing PWM outputs. PWM stands for pulse width modulator, and that is the phenomena that is used for controlling the motors, servo motors, or even the speed control of DC motors. So when we learn motors, at that time we will understand what is the PWM. PWM is also called as a digital way of producing analog results. So that is what I wanted to highlight. Now few more of the highlights. We have an internal onboard power circuit. That means if you want to give power to any peripherals, then we have got these. In this section you might see that we have written 5 volts, 3.3 volts, ground and ground. So these 4 pins are there because there are few sensors which require. Now the sensors can be an active sensor or a passive sensor. Active sensor requires voltage for operations, such as Arduino requires voltage for operation. In the same way, all sensors require voltage for operation. Now to provide 5 volt to it, we need not connect a separate battery for that. We can provide voltage to it with the help of a 5 volt pin that is provided here. So few sensors work on 3.3 volts, so we can connect 3.3 volt from in here. And to provide the circuit ground, so we provide positive voltage, there should also be a path with the help of which the current flows back into the board. Therefore we have 2 ground pins in here that are available. Along with that, one more additional ground pin is there above the 13 number pin in our digital section. So this is all that we need to know now. There are a lot of other things that are there, but there is no need for you to go into the details of it. That is the beauty of Arduino. Learn only few things and you can directly go for operation, and later on in the stage we can learn that. Now the most important part is of this Arduino board is this IC. This is Atmega 328 IC. As we have seen earlier, it is an Arduino is open source hardware platform based on Atmel AVR microcontrollers. So this is the microcontroller Atmega 328. Now this is an 28 pin IC, and if you were making an embedded system using this IC, then you have to take this IC, you have to provide it an crystal oscillator for operation, and you also have to make an PCB, then you have to remove those pins, and all these things are necessary. But when you buy this Arduino or you take this Arduino, everything is done here. So you have to just connect this through wires to the sensors and it is ready to work, because this board itself has power supply things and all the things are simplified, and it also has a port through which we can connect it to the PC. So this board simplifies the hardware structure. If you have any queries, you can find us on Facebook by the name Million Lights. Similarly, you can also find us on Twitter. You can visit our website www.millionlights.org for more interesting courses. Thank you.